is like, take some region in the plane, for example, this region, and then rotate it around an axis. Okay, so I tell you, for example, I take this region and I rotate it kind of around the y-axis. What shape do I get? What was that?
Cone.
A cone. You guys see that? Like kind of a pointy cone, right? With a small base, right? This would be the base of the cone. Kind of double that. Does that make sense? And then, the other half, in the profile would look like that triangle, but it's kind of a circle around. Does that make sense? If instead I kind of rotate it around this way, what shape would that be?
Another cone.
It's still a cone, but it would look different, right? You guys see it'd be like a shorter cone with a bigger base. Does that make sense? What if I did something like this and I rotated it around this axis? Yeah, like a solid ball, like a sphere, like a sphere with stuff inside. Does that make sense? What if I took something like this and rotated it around that axis?
It would be like missing part of its middle. It would be like a washer.
Well, actually, this would be solid. There'd be no hole because it actually would connect down there. Does that make sense? Like it'd be the profile would look like if I took a slice, it would look like this, right? This kind of leafy thing on top and a leafy thing on the bottom. They'd be connected at this point. So it's like, maybe I'll start with a slightly different one. What if I had this? And rotate it around the same axis. Yeah.
It would be like a disc with like a curve inside.
A disc.
Like it would like form like a cone but open. on the
Right, it'd be like
outside.
a cone with kind of like curvy stuff dug out from the middle. Like into the middle. Does that make sense? What if, and then if I did it with like this part, it would be the same kind of thing, but instead of a cone with straight edges, it'd kind of be curvy on the outside and curvy on the middle. Okay, does that make sense? But somebody mentioned washers, right? So where might washers come in? Say I have this region here, and I'm rotating around this axis. What would that look like?
That one would have like a hole in the middle.
Right, like a big hole, it'd be like a dog bowl almost. If you think about it, like on the outside, it would be kind of straight up and down. And then there'd be like a curvy kind of rim on the inside, and then it'd be kind of empty in the middle. So maybe like a crown, like a tiara or something. Does that make sense? So you're okay with that kind of? Okay. So maybe by now you kind of see how we're going to solve these problems, right? We're going to take a little slice, like to find the volume of the cone. What we're going to do is maybe something like, if I take a slice of this, and when I rotate it around the axis, what do I get?
The cylinder.
Like a very short, skinny cylinder, right? So I find the volume of each cylinder, each disc, and I add them up. Does that make sense? Same thing here, right? If I take this, and when I get a disc, I take find the volume of each disc, and I add them up. See, I rotated this one around here. Do you see I'd probably do the same kind of thing? I find that little rectangle, rotate it around. It's a little different in this case though. What happens in this case? Do I get a disc when I kind of rotate that little yellow rectangle? I get like a disc minus a disc, right? So I get a washer in that, at that point. Okay. And by washer I mean, right, like the stuff you see in a sink, right? It's like something like that, like a disc with a hole in it. I guess quickly, how would you find, so the volume of these discs are something like pi r squared, right? What's the formula do you think for the area, for the volume, or yeah, the volume, I guess, of a washer? Yeah.
the outside curve minus the inside?
Right, can you be a little more precise?
Like the outside curve plugged into pi r squared.
Okay, it's like pi, the outer radius squared, minus pi, the inner radius squared. So that's gonna be the volume of a washer like that, right? What this is the outer radius, and that is the inner radius. Okay, does that make sense? Any questions about that?
For the volume, would you still multiply all that by the height, or no?
Yeah, so this is the, that's a very good question. So that's good. This is like the air, like the stuff we've been doing. This is like the area of the face. And then you're right. It's going to be times dy or dx depending on kind of how you slice it. But that dy dx means exactly the height of the cylinder or the line. Does that make sense? There is another way to do these. Called like, they're called cylindrical shells, right? So I'm just gonna preview it. I could also slice it this way and rotate it here. And then each volume there would be like a very tall cylinder with a big hole in the middle. Does that make sense? So if I rotate this around, right, I get a shell, like a shell like this, that's empty and as long as the function is tall. Does that make sense? So that'd be another way of doing it. We're going to focus on discs and washers today, but that's kind of another one we're going to see. Okay. So we're going to be doing this. In this case, we're going to be slicing perpendicularly to the axis of rotation. So that's just a fancy way of saying, right, if I'm revolving around here, and I have a region that looks like this, right, I'm slicing it, right, here's my axis of rotation, and I'm slicing it perpendicular. So I'm doing a dx integral. Okay? I could also have the same region, and for some reason choose to, same region, I'm sorry, but now say I'm rotating it around here, I would slice it this way to get my discs or washers. So this, yeah,
That would be dx and that would be dy.
and this would be dy. dy because the thickness, the really thin thickness, is a little piece of the y-axis. And this- Does that make sense? So what do I need, right? I really need to kind of right, by kind of setting up and drawing the picture, I'll know if it's dx or dy. So what's left to find is kind of the volume of each little slice. Okay? So let's set up a problem to see how it works. That one doesn't slide. Okay, so let's set up this interval, or this problem. So find the volume, generate it, by rotating the region bounded by two functions. Right, so one function is y equals x squared plus 2. And y equals 4 minus x squared. Okay, so that's the region. Like I have this parabola x squared plus 2, and this other parabola 4 minus x squared. And I'm rotating it around the line. y equals negative 3. So I'm going right to like the hardest version of the problem. Because I think the ideas that you get by kind of processing this, it's easier to kind of simplify to easier problems than kind of build up to a more complicated problem. Because it's just the same idea every time. Okay, does everybody have a statement of the problem? So you understand what I'm asking? I have a region, and I'm rotating around the line y equals negative 3. Right, I'm trying to find the volume of the thing that I get by rotating. Okay? So what do you think step 1 is for this? Yeah,
Graph it.
graph it. Always, almost always, when you do the integral, draw some kind of picture. So what does this guy look like?
The y-intercept is 2, so it's gonna start at like 2 above on the, y-axis.
So what is it though?
Upper out,
A parabola. Is it smiley or sad?
smiley.
Like it's opening up, right? So it's a parabola, it goes through 0, 2, and inwards. So this is. What about this guy? Yeah.
You start at 4 and you do close, close problem, or,
Close parabola.
no, never mind, like upside down.
A sad parabola.
Yeah.
So it's sad parabola, and it goes at 4, right? So something like that. Let me draw those in different colors. Okay, so now the next thing, so I've drawn the region, right? It's that region, that eye look region there. Where am I rotating it around? Yeah.
Y equals negative 3.
So what's that? That's a line. That's 3 down below, right? So I'm taking this region, right, and rotating it around there. Okay? Is it clear to anybody or most people, am I doing dx or dy? Which one am I doing? dx. Is everybody okay with that? Because I'm rotating around here, so my little rectangle is something like this, right? So that thing gets rotated around. Does that make sense? Is everybody okay with that? So then, what I'm doing, right, is I'm taking, well, I guess, what's one more thing I probably need about the graph? I wanna like set up the integral. Yeah. Where they intersect. Okay, yep, so I need to find this point. And I need to find that point. And how do we do that? We set them equal to each other. So I get x squared plus 2 equals 4 minus x squared. Right? So I get 2x squared equals 2, x squared equals 2, x is plus or minus 1. Are those steps okay? So my integral is going to go from -1 to 1 times dx. We've already established all that. So what's left to do is to find, so remember we had this formula, right? Pi times the outer radius squared minus pi times the inner radius squared. Is that right? So our job is to find the outside radius and the inside radius. that okay? If we can find this and this, we're in good shape. These things depend by x, right? So in a sense, the outer radius depends on x, right? The outer radius is right this far at that x value. Do you guys buy that? Right, and it's maybe this long on that x value. So the point, it kind of varies at different x values, but we know at least a couple to kind of check our formula. Right, so for example, the outer radius at 0, what should the outer radius at 0 be? And that should just be a number. That's a number we should know. So if I write down my formula that I'm about to write down, if it's right, I can check the value at 0, for example. What's the value at 0? How big is my outer radius at 0? Well, let's draw that on the picture maybe, right? So at 0, right, this is the center of my shape, right? So the outer radius is this length all the way up to there. Does that make sense? And that's a number, right? What is that number? It's 7, right? So it makes sense? Because it's 3 to get here, and then 4 to get here. And that's 4 because this is y equals 4 minus x. Do we know another value? At 1, what is the outer radius? So at 1, it's going to be this length here, right? Is that okay? And so what's that length? Okay. 5. Why is it 5?
Because the intersection is, it's at 1, 2.
1, 3.
Oh, sorry.
If I plug in x equals 1.
Yeah. And then, from y equals -3, like the line from to the, oh, it's actually 6.
Yeah, that length is going to be 6. You guys buy that? So you're going to try to write it down in general for any x, but we at least you have 2 points to kind of check our answer. In fact, you have a third, right? What's the third point where we know it? A -1 is also going to be 6 because of the symmetry. Does that make sense? So let's try to write it down and see if it at least agrees on those 3 points, and then at least we might be in the right ballpark. Okay? So I need to find my outer radius. So outer radius as a function of x. Right, why is a function of x? Because it varies by x, and because we're doing dx. Okay? So how far would that be? Do you buy we have to add 3 onto whatever we do because of the 3, this kind of artificial 3 that's right here? We're going to have to do this plus the value of the function. Does that make sense? Is everybody cool with that? So the outer radius should be this plus how far I need to go from my x to the yellow curve. So that's going to be 3 plus 4 minus x. If you want to think about it a little less geometrically and more algebraically, depending on how you think, I like geometric better, but if you like algebraic, you can think of this again as top minus bottom, or right minus left. Where here the top is 4 minus x squared, right? That's the curve on the top, and the bottom is minus 3. You get the same thing if you prefer algebra or if you prefer pictures, but you can go with whichever one you want. Is that okay? What is the inner radius? Oh, I'm sorry, let's check to make sure that the 2 values I said work, right? At x equals 0, what do I get? I get 7, which is the 7 that we got over there. And when x equals 1, I do get 6, which is the same thing we saw when we looked at the picture over there. Okay, so it matches up with kind of those particular values. How do you find the inner radius?
plus the x squared.
Exactly. It's 3 to kind of get from the orange to the axis, and then the function to get up to the function. So that's the, yeah.
How come for the out, it doesn't also add the x squared plus 2 if you're going upwards to the very high point?
Well, so I'm going up to the yellow, right?
Yeah.
So I just need to find,
Oh.
the yellow is kind of that part right there, and then the 3 is that. Is everybody okay with that? So if I do a little bit of simplification, so usually just for laziness, so I don't write pi both places, I'm gonna pull out a pi, because it's gonna be like pi outer squared minus pi inner squared, so it's gonna pull the pi out, right? Then it's gonna be outer squared minus inner squared. And that's the volume of that cell. Yeah.
For the R in, why wouldn't you have 8 plus x squared?
I'm gonna have what, I'm sorry?
8 plus x squared.
Oh, because that, I just got ahead of myself. The actual problem is x squared plus 2, not x squared plus. Yeah.
It would be minus x squared, right?
Oh, yeah. I'm on 5. 7 minus x squared. Okay, does that feel okay? How could this problem be different? If I was rotating around an axis, things get a lot easier. Right? What would the difference be? What would the outer radius be if I was rotating around here?
4 minus x squared.
Be 4 minus x squared, right? I don't have to worry about that 3, right? And the inner radius would be x squared plus 2. So I don't have to worry about that if I'm rotating. What if it was just this all the way down to here? How would that change? So I'm just looking at 4 minus x. There's no longer a x squared plus 2. How would things change?
It would just be 4 minus x squared.
Right,
Is
there's
your
only one,
R.
there's no inner radius anymore. The inner radius is 0, so it kind of disappears. Right, so it would just be pi outer radius squared, which would just be these heights here. In this case, the interval would change from -2 to 2 instead of from -1 to 1. It would just be 4 minus x squared squared times pi. Does that make sense? If I rotated stuff, does that make people nervous? Meaning, if I had something more like this and rotated around the y-axis. Do folks worry about that? Yeah.
I don't really understand how the rotation works. Like, I don't know how the shape is being rotated and like what it becomes after the rotation.
Right, so like if I rotate this around the y-axis, what does that mean? It means imagine like it's a little piece of paper, and imagine what the paper traces out as I move it around.
So doesn't it still stay the same shape?
Well, I mean, this would be a cone when I rotate it. Do you buy that?
Yeah.
And it'd be a cone pointing down, right, with kind of this base and that height, right? If on the other hand I rotate this around the x-axis, I get a totally different shape, right? Because it now kind of comes out here. And all this stuff in the middle, it's not leaving any trace. So if I rotate this around the x-axis, it would be something, and I apologize in advance. Yeah. Yeah, I can't even. So the way I described it was like imagine like a bowl, right? Where the middle was hollow, the middle is empty. The middle is empty because of this. This isn't kind of sweeping anything out. But the edges of the bowl are kind of these little triangles. Does that make sense? So the big cross section would have two triangles. And anywhere I slice it at any angle, it always looked like these two triangles. Which is very different than the cone you get by rotating it that way. Does that help? So yeah, I don't know. Can you imagine? Have you ever done a lot with like bubbles, like blowing bubbles or anything like that? No. Okay. But I think the way to think about this for me is the solid that kind of ends up, no matter how you slice it, you're gonna get a cross section, and then it's kind of the same cross section no matter where you slice it. So if I rotate it this way, the cross section is this triangle here. So that's why it's a cone. If I rotate it this way, the cross section is two triangles that are far apart. So the cross section looks kind of like my fingers, right? With a kind of a solid here and a solid here. Imagine kind of rotating that around, and that's the solid region. Does that help? Okay. If anybody's like great at 3D printing, you could print these out and bring them in, and you would make people very, very happy.
One circle on the top and two circles on the bottom.
Connected by a triangle, yeah. And that's what I was trying to say, is like a bowl with the middle being hollow, and the walls are kind of coming in at triangles instead of coming in straight down. But I guess the question was that if I kind of asked you to kind of rotate this way, are folks kind of okay with the same picture? I have to do like right minus left instead of top minus bottom, or something like that, but be dy and basically the same set. Okay. Questions about that? Do you want to see a dy one just to kind of make sure things are okay, or do you want to kind of practice a bunch of different ones? See a dy? Okay. So volume by rotating y equals square root of x minus 1, or by rotating region bounded by y equals square root of x minus 1, and y equals x minus 1 about the line x equals negative 1. Okay, so the function is the region bounded by square root of x minus 1 and the line y equals x minus 1. So that gives you a region, right? And then I'm rotating around the line x equals negative 1. Okay, so let's. So what's step 1? Yeah.
Draw a picture.
Draw a picture. So what does y equals x minus 1 look like? We'll do the second one first. That's just the line, slope 1, intercept negative. Okay. So you get this line here. Do you guys know what y equals square root of x minus 1 looks like? It's like half a parabola. What are its x-intercepts? Yeah, when y equals 0, right, x equals 1. So since it goes through, it starts here and goes like that. So, okay.
What's that word next to region?
Bounded. it's a lazy way of writing it. So the yellow is y equals square root of x minus 1. Okay. And where am I rotating it? Around the line x equals negative 1, right? So that's over here.
Is it possible, I know this is like a crazy question, but is it possible to have one of these questions where instead of just rotating over one axis, it rotates over both, or no?
Like in 2 different steps.
Yeah.
The challenge with that is I think you kind of get like double volume, like you kind of like overlap in some cases, and that would be, you have to kind of decide how to handle that. I don't know the right convention, so I'm not gonna ask something like that.
Okay.
But I could ask you something where, by symmetry, if I rotate this around the line x equals negative 1, I do see how this is kind of rotated. To find this, you could just find the top half and double it, which could make something, you could kind of use symmetry to your advantage in some of those kinds of things. So I'm not gonna ask you to like rotate and then rotate.
Okay. All right, thank you.
Okay, so we rotate around that x, so what does a little slice look like? Is it a disc or a washer? Or a washer just a disc with a hole in it? Is it a disc or a washer?
Remember the wash.
It's a washer, right? Is it horizontal or vertical?
Horizontal.
Horizontal, because I'm rotating this way. So if I draw that little kind of slice, right, and if I rotate that around the x equals negative 1 line, I get my washer. Okay. See this? So it's the same formula, right? It's gonna be pi integral outer radius squared. But now the outer radius is gonna be a function of y, because I'm kind of going up and down, minus the inner radius squared, and then dy. So I need to find formulas for the outer and the inner radius. Is that okay? And again, it's good for me at least to have some points to kind of check in my mind. What should outer radius be at 0? One. Why 1?
I'm assuming is it from the y equals square root of minus 1, and that's from the integral. I don't know.
Right, so I think this is at the point 1, 0. But that's not my outer radius. My outer radius comes from here. I'm sorry, my outer radius in this case comes from here. So what should that be? 2, right? 1 to get here, and 1 to get to the point. So the outer radius at 2 is 0, so is the inner radius, right? Because the outer radius at 0 is 2, and the inner radius at 0 is also 2, because that's where they intersect. That makes sense? And similarly, you probably want to find this point of intersection. So where do those two guys intersect? Let's do the things we do. We set the y's equal to each other and find the x. So how do I solve something like this? Square both sides. If I square both sides, I get x minus 1 equals x minus 1 squared. Maybe I pull things over to the right. Or to, yeah, move everything over to the right, so I get x squared minus x minus 1 equals 0. Maybe I factor out an x minus 1. That gives me x minus 1 minus 1. Is that okay? So this becomes x minus 1 times x minus 2 equals 0. So the other point intersection is at 2. Is that okay? So x equals 2. That's the y coordinate there, so at the point 2, 1. Is the other point to the intersection. That's not good. You could do this without factoring, you could kind of multiply it out and do a kind of formula and stuff like that, but in this case, I just pulled out the x minus 1. So what's the limits, what are my limits of integration gonna be then?
If you're rotating it around the x-axis and it's in terms of y, would it be 0 or 1?
It would be 0 to 1. For the lowest slice happens at y equals 0, and the biggest slice happens at y equals 1. Okay, so it'd be from 0 to 1. And so all I need now is an expression for the outer radius. So what's the outer radius? It's gonna be 1 to get to here, and then the function to get the rest of the way, right? So right now I have it written as y equals x minus 1. I'm gonna write that as x equals y plus 1. Is that okay? So at any y, I'm gonna have to go 1 to get to the y-axis, and then go y plus 1 to get to the line. Does that make sense?
For that over there, why did you add the x minus 1 minus 1? Where did that come from?
I factored out an x minus 1 for both of these. Right, so I have an x minus 1, and then if I factor an x minus 1 from here, I'm just left with the x minus 1.
You just okay,
And if I'm left with, if I pull this guy out, I'm with minus 1. So it's just minus 1. Does that work for our, we should check to make sure that the outer radius at 0 works as expected. Geometrically, we saw it should be 2. If I plug y equals 0 into this, I do indeed get 2. So at least that point works. So the outer radius squared minus the inner radius squared. So the inner radius squared is going to be the quadratic guy. So I'm going to have to take this guy and solve for x. So that's going to be y squared equals x minus 1. So that means x is going to be y squared plus 1. Is that okay? So then now the inner radius is going to be, I need 1 to get to here, and then the function to get the rest of the way. So it's going to be 1 plus y squared plus 1 squared. And we can maybe check again, right? What should the inner radius be at 0? The inner radius at 0 should be, it should be 1 plus 1 should be 2. And you can see that that works there. At y equals 1, what should the outer radius be? It should be 1 plus 2, it should be 3. And if I plug in y equals 1, then it's 3. So at least those consistency checks work out. Yeah, so makes sense? And then that's it. That's the integral that you do for this guy. Any questions about that? Okay, so let's practice some things. So you feel free to talk to people around you. The first page is kind of an area review a little bit, and then the second two